Hello, my name's Chris Ward. I'm an applications engineer with Fenner Drives. Today we're going to go through an installation of Power Twist Drive. During the installation, my colleague Brad Tucker, who is also an applications engineer with Fenner Drives, may be asking me questions. He's going to act as a student, so he'll ask questions as we're going through it. So with no further ado, Power Twist Drive, Power Twist comes in a box just like this. So what we're going to do is we're going to strip a piece out of the box and we're going to hand fit the belt around the two pulleys. So you can see here what we have is we're simulating a drive fan on a roof. We have a drive pulley and a driven pulley. You can see that they're different sizes. So we're going to take our piece of Power Twist Drive. We're going to hand fit the belt. Keep stripping some out of the box. We're going to hand fit the belt into the groove. And we're going to pull it tight in the groove, and then what we're going to do is we're going to overlap two tabs. So you can see here, hopefully you can see here, and I'll show you in a second, that these two tabs here are going to replace those two tabs there. So what I'm going to do is I'm going to stick my index finger between those two tabs. It is a little bit subjective. Obviously, we're all different people have different strengths. I think you'll feel it with this belt when it's gone tight. I don't think you need to swing on it. It is a little bit subjective. My finger's still between the two tabs. I've bent it. You can see that one tab points north and one tab points east. I'm going to twist that one tab first, pops up, second one comes out easily. The part that goes back in the box, I can put aside. I don't need that anymore. So now I have a piece of Power Twist Drive that is exactly the right length for our application. Let me just show you. So I'll put it in the groove, push it back, pull it tight, and you can see that those two tabs are going to go through those two holes. Okay. So in the past, we have told you that you have to count every one of those links. But now, with Drive, we've come up with a slightly different method, and we're going to make it a little bit easier and a little bit quicker for you. We're going to take a tape measure, and we're going to measure from end to end. We're not going to measure just the tabs. We're going to measure from end to end of the belt. So let me grab a tape measure. I'm going to ask Bradley to step back in and just hold one end of the tape measure on the end of the belt. And we'll pull it tight, and I'm getting 76 and a half links, 76 and a half inches. And I'll show you it, it's upside down, 76 and a half inches. Now, from that, with that piece of information, we go to our installation instructions, and on the very first page, we're using an A-section belt, and it'll say, for a length in inches, and we said we had 76, it goes from 63.2 to 80.3. And obviously 76 and a half is right in the center of there. So what it's telling me is I have to remove 4 links to get the correct tension. Now, people say, well, wouldn't that be tight enough as it is there? Absolutely not. It's only as tight as we can physically pull it. And that's certainly not enough tension for a frictional drive like this to function correctly. So I'm going to go to the end of the belt, and I'm going to remove 4 links because that's what our instructions told me to do. There's our 4 links out. So now I can assemble the belt. We have access to the pulleys, so I can assemble it off. In some applications, we may need to do this over the shafts or actually on the piece of equipment. That's easily done as well. So how it goes back together is one tab goes through the 2 holes, first tab through the 2 holes and twist. The second tab has to go through that second hole. So what I'm going to do is I'm going to pull down with my right hand, I'm going to twist that tab with my thumb. That makes it easy enough where I can then just put over the top. So now the belt's been put back together. As you can see, it's inside out. It's not going to work inside out, so we turn the belt the right way around. And in this case, I have a mechanical advantage. So I'm going to put the belt in the groove of the small pulley and I'm going to put it onto the larger pulley. So you can see the belt started to go tight. It's in the small pulley. We need to be really, really careful when we roll this belt on. There are some trap areas or some pinch areas. So I don't want to put my hand anywhere in this area where I could nip my fingers or my hand between the belt and the pulley itself. I've got to hold on to the belt very, very tightly, because if not, as I turn it, it's just going to want to keep jumping out of the groove. So yes, I've got hold of the belt very tight and I'm pushing down, keeping the belt in the groove. Second hand comes on. As we're going to turn it, I'm going to keep my hand away from the trap area, and it rolls on, and it goes on nice and tight. So we get asked a lot of the time, there's a little bit of subjectivity to counting there. So what we've done is we're going to take the brain work out of it for everybody. So we're going to provide customers with a force deflection gauge. It's a fairly straightforward tool. And most of the maintenance guys out in the industry will be familiar with such a tool, because it's something that's been used in the rubber V-belt industry for many, many years. Basically, what we do is we're going to do a calculation. We're going to work out what the center distance is by measuring it. And for every 1 inch of center distance, we're going to want 1/64th of deflection. So we're going to measure the center distance and see what we need to set our force deflection gauge to. I'll ask Brad to just step in a second for me. So we'll put it across, and we're about 24 inches. So the math works out, we're 24-inch center distance, so that's 24/64, which divides down to about 3/8. Well, it divides down to exactly 3/8. So what we're going to do is, on our force deflection gauge, it's both imperial and it's metric. Obviously, we're going to deal with inches, so I need to set this to 3/8. So I find my inch scale, I slide that little rubber collar down to 3/8. So now my collar's set to 3/8 of deflection. So what we're going to do is we're going to push this belt down until we get 3/8 of deflection and see how much force it takes to do that. So on the other end, this is the force end. You can see we have another little rubber collar. We're going to slide that down to the 0 mark, because we're going to push that out and see where it finishes. So ask Brad to step back in for me, and we'll put a straight edge on there. Now, if you've got multiple belts on here, it's really, really nice. You don't have to put a straight edge on, because as you deflect this belt, the belts behind it don't deflect, and we can take a gauge off that. In this case, it's a single belt, so we have to put a straight edge behind it. So I'm going to put a straight edge on there. I'm going to find about half span. I'm also going to make sure that I push on top of one of the links. Obviously, I don't want to push down in one of the troughs. So mid-span, about here. I'm going to put my force deflection gauge on top of that. I'm going to press down until the bottom of that rubber hits the bottom of my straight edge. Thank you very much. And then what we'll do is going to read off how much force we've actually got. And it looks like we're about 5 pounds. So from that, I need to go back to my installation instructions. And on the second page, it gives force deflection guidelines. For an A-section belt, it's a brand new belt. It says that I should have 4 to 5 pounds of force. And obviously the center distance determines how much deflection. So you can see we're about right. Now, if this was a belt that had already ran in, the force deflection is a little bit different. So we would, if you look at the gauge, it says a belt during operation. It says we would need to put 3 pounds on there. The reason for that is, as a brand new belt, in pulleys that may have been used before, it's going to seat itself and find what we refer to as its happy place.
So will anyone be concerned about the tension in regards to bearings?
Yeah, in the past, when we've put belts on, everybody believes that it goes on extremely tight. And a lot of people say, well, that's going to damage my bearings. I think what you find is the difference in tension between this and a rubber V-belt is not significant. We're going to lose a little bit of tension, even though we have seated the links with drive. It's going to elongate probably 0.5 to 1%. And you'll see the tension drop off a little bit. As the tension drops off, the end load on our bearings is certainly going to be reduced as well. So I don't see it as a concern. The force that we're putting there is fairly similar to a rubber V-belt. So the last part of installation and deinstallation is, how do we get the belt off? Can we get the belt off once it's nice and tight on there? And the answer is yes, we can. Again, there's pinch areas here where we need to be really, really careful that we don't trap our hands in there, and it's fairly straightforward. You can push a belt, you can pull a belt. What we're trying to do is move that belt out of the groove. So I'm going to put my hand on here so that I can turn. I'm a puller, so I push my thumb against the flange, and I'm going to pull the belt towards me. As I pull the belt towards me, you can see it clears the groove, and with that it snaps off. Let's just put it back on, so we've finished with it back on. Back around the small pulley, use the mechanical advantage. You can see the position of the belt, hand out of the trap area, give it a turn, and it snaps on and goes back on. That concludes our installation for Power Twist Drive.